we move to another vector database. This one is FAISS, FAISS, okay. So full form is Facebook AI Similarity Search is a library for recipient similarity search and clustering of 10 vectors content algorithm that search inside of vector of any size up to one that possibly do not fit in them. It also contains supported code for evaluation and parameter tuning. Okay, so third uh, also a vector database. Okay, so here we need to create this is the file. I'm going to write code here. Okay, so here I'm going to I need to copy the code from there to here. Okay, select the virtual environment now. Okay, so here you can see from LangChain community document loader import text loader. Okay, and here you can see from LangChain community vector DB prefers to import files FAISS. From LangChain community I need to import embedding equals to embedding equals to Olama embedding. Okay, so here you can see fourth one LangChain text splitter. Here I'm going to import character text splitter. Okay, so we are going to upload documents. So this is the document. Here this is the document. Okay, we are going to use text loader from LangChain. Okay, LangChain community document loader. Now we can see text splitter is equal to character text splitter. Here we are going to do chunk size equals to 1000 and chunk overlapping equals to 30. Doc equals to text splitter split document. Okay. Open embedding is not accessible. File locally run large language model to follow the instruction. Okay, but I already have Olama. And I already run. Okay. Okay, so here we can see in this file we imported all necessary libraries. In here we are going and we load our text data. Okay, in text format documents. Here we are going to load our document, and here we are going to do some silence and overlapping. Okay, and here text splitter equals to split the document. Okay, so document will be split in this format, like in different documents. Okay, so this document is getting into this document. Okay, so source equals to this speech.text, and this is the content. Okay, for we give chunk size and chunk overlapping. Fighting for Harry play we perform to be fighting for. Okay, so this is these are the documents. Okay, after that initialize Olama embedding. So here embedding equals to Olama embedding. I'm going to use this model. You can use any other model from Olama. Here initialize the Olama embedding. Use embedding model. Okay, and after that we need to create a vector store to db equals to say dot from document dot embedding. Okay, here I'm going to ask query how does the speaker describe the desired outcome of the one. Okay, so So here is the similarity and this is the page content of 0 dot. Okay, I mean index 0. So if you ask to query from this, then it will use similarity search. It will search based on the meaning, not from the keyword, and this will get the answer. Here it is the history, opinion, appraisal, duty. Okay, so this is that. This is the page content of the zero document. Okay, so as a retriever equals to db dot as a retriever. Okay, so dot equals to retriever dot remove query. Here you can see document 0 dot page content. So we can also convert the vector into a retriever class. This allows us to easily use another LangChain method which largely works with the retriever. Okay, here we can use similarity search with the score. So there are some size specific methods. One of them is similarity search with the score, which allow you to return not only a document but also the distance score of the query to them. The return distance score is equal to distance, therefore a lower score is better. Okay, here this is the query. I mean, this is the document and score. Lead or similarity search with score and see. We pass query and return document and score. Here you can see embedding plus embedding of the query and embedding method. We have the embedding. Okay. Doc is code. Here we are going to calculate doc is code. So this is the score. And we need to save this, saving and loading the model. So you can see we are going to save here. This is the third index. Okay. You can see here index third and index critical. Okay. Now we are going to create new variable new db third or log third index. Okay. We are going to load this third index. Okay. Here we are going to pass embedding, allow, then rest deserialization. Okay, here you can see what is then rest deserialization. Okay, whether to allow deserialization of the data which involves downloading a pickle file can be modified via malicious actor to deliver any malicious payload that results in an execution of the arbitrary code on your machine. And that is equals to true. Okay, so dot equals to new db similarity search query. So here I am going to ask the query from this database. This already saved file. Okay, so now we are going to print this document. So here these are the documents. Okay guys, I think you got it. If you want to do what's it one more. Okay guys, this is the third vector database. Bye bye, take care. See you next video.